So we're going to now take a look at the reason why your scientific calculators and the calculator on your phone and any other calculator that you use that is not one of those cheapy dollar store ones that has very few functions has the buttons sine, cos, and tan. Or sin, I think is how most kids say it. Sin, cos, and tan. They actually stand for sine, cosine, and tangent. We're going to take a look at why. So there's going to be some naming conventions we'll go through first here. And then we'll look at some actual problems that you can solve with some of these ratios we'll set up. It may be a little confusing at first. Bear with it. It takes some practice, but once you start practicing with it, they usually flow a little quicker for you. They're three very similar setups. But first, some naming. So we need to be able to name the sides of our triangles. This is one of the main reasons why students struggle when they get to trigonometry, is that they don't take care in naming the sides of the triangle. If you mislabel the sides, then you will not pick the right ratios and get incorrect answers. So, naming the sides. First off, we're only working with right angle triangles for these trigonometric ratios. So we're only going to be working with right triangles for this bit. So the hypotenuse is always that longest side, again pointed at by the right angle. Now, if you recall the rise and run, we said the rise is always opposite the side that is, or the angle that we're working with. So this is opposite. It's the furthest side away. Okay, the rise is the furthest side away. It's opposite. So we call it the opposite side. In trigonometry, we use the term opposite, meaning the furthest side away, the rise. And again, the rise will not always be going up. Now it's not rising, but it's still called the rise because it's the furthest side away. It's the opposite side. Okay, so the opposite side of the triangle is always going to be for the furthest away from the angle. The run is then called the adjacent. So that's the adjacent side. Now, we got some triangles here. They're kind of in some different configurations where I have the same triangle, but I've moved the angle that we're working with each time. And we'll see how that changes the triangle. So in this first one, let's label the hypotenuse first. I usually do that first because it's the easiest one to do. So I'll just put HYP for hypotenuse. It's across from the right angle. Now, here's my angle I'm working with. This is the working angle. We never work with the right angle, by the way. We always are working with one of the two smaller angles. Okay? So this angle here, the opposite side, the furthest side away is over here. So that's the opposite, PP, and then the adjacent is the remaining side. So one of the things, if you're like, I can't remember all three of those, you should know the hypotenuse from Pythagorean theorem, and just remember that the opposite side is the furthest away from the angle that you're working with, and then the other one is the adjacent. In the next case, same idea. Start with the hypotenuse. So there's my hypotenuse, the longest side across from the right angle. Now my angle has moved up to here. My working angle's up here. That means the furthest side away is now down here. Opposite, and then this has to be the adjacent. So notice the opposite and adjacent have moved. The hypotenuse is not, but because I switched where the angle was, I had to switch where the opposite and adjacent are. Same thing on the rest of these. The hypotenuse is the longest angle. The longest side across from the right angle. And then whatever's across from the working angle, the opposite is here. The opposite is over here. So again, same triangle, but because the working angle's moved, then our opposite side has moved to respectively be the furthest side away. And then the remaining side is the adjacent. One more try at that. Again, hypotenuse, your longest side in your triangles. And then, given my working angle here, the opposite side is the furthest one away from it. So this is the opposite here. This is the opposite here. Thus the adjacent and the adjacent. So moving that angle, moving that working angle, moves the opposite and adjacent. The hypotenuse always stays the same. So that's naming those sides on those triangles. Now, getting into the sine, cos, and tangent. The sin, cos, and tan is... kids pronounce abbreviations instead of noting that there are abbreviations in the whole words. So sine, cos, and tan, cosine and tan are here. So given this triangle from our similar triangle setup, if we have an angle down here, You'll note the ratio of the sides is the same for each of these triangles. They all share this angle theta. This side divided by this side, the opposite divided by the adjacent side. Right? This is the opposite, this is the adjacent, and it's the same in all of them. The opposite divided by the adjacent is 0.5. The opposite divided by the adjacent is 2 divided by 4, that's 0.5. The opposite divided by the adjacent, 6, 3 divided by 6, is going to be 0.5. They all have the same ratio. And that is what we're going to be working with. There's a set of ratios included with the lesson on Edsby. You will find a giant sheet that has all the ratios from 0 to 90 listed. If the angle is 0, this is a sine, cosine, and tangent ratio. If the angle was 24, here's the sine, cosine, and tangent ratios, respectively, for the angle of 24. They are consistent. Those ratios never change for any given angle, no matter how big the triangle gets. And it's the same if you compare the hypotenuse to the opposite, root 5 divided by 1. The hypotenuse to the opposite here is 2 root 5 divided by 2. That'll still be root 5. And then 3 root 5 divided by 3 would still be root 5. So the ratios never change, and so we can use these constant ratios to help us find missing sides or angles given known information about the triangle. So the ratios that we will be comparing are the opposite and adjacent, the opposite and hypotenuse, and the adjacent and hypotenuse. And they will, again, be the same for any given slope angle. So the angle of this slope here, they're going to be the same. So I flip that over. These here are the formulas. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And an easy way to remember these formulas is the phrase so. Sine opposite over hypotenuse. Ka. Cosine is adjacent over hypotenuse. Toa. Tan is opposite over adjacent. So katoa. Many of your teachers will use it. You'll see, I've seen it in textbooks. I've seen it on classroom walls. This is a very common way to remember the setup. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. It's always something like that. So the formulas are always going to be laid out with that same format. And then it's just a matter of picking which formula to use. Now, before we get into actually calculations with these, it's important to note a few things. One is, how the heck do you do all this stuff on your calculator? Well, in the case of sine theta, you could just press sine 45 or 45 sine, depending on the way your calculator works, and you will get the result of 0.7071. But if you're already given the ratio, so some questions we need to find the decimal, the ratio. Some questions we need to find the angle based on that. So when you do that on your calculator, what you'll see is this. In my calculator, I press the second button and then sine. I should show that a little better here. So I press second sine, and then I can type in my decimal. Here's 0.8509, and I'll hit equals, and I'll get 58.3096. Your calculator might be different, where you type in the decimal first and then do the second sign. So it just depends on your specific model of calculator. So you need to test that out. One of the problems that does arise with the calculator, though, that you have to be careful with, and why I recommend using the trig table that I've provided rather than a calculator, is that your calculator has 2 modes. Or 3, depending on your calculator. Mine has 2. There's radian and degree mode on my calculator. Some calculators have another one, radians. But radians is a different measure of angles. And most computers, and you'll notice it comes first because my calculator actually defaults to radians. I have to change it to degrees. And on your calculator, you might see sometimes at the top here, there might be a DEG or a D or an R or an RAD. If that's up there, that means that your calculator is in that mode. So D or DEG means degrees. But if it's R or rad or G or grad, then you're working in the wrong mode and you will get the incorrect answer every time. So make sure that you figure out how to change your calculator's mode. Most calculators, if you just hit the reset button that's usually found on the back, push it with a pen or pencil, that will fix that issue and it'll go back to degree mode. Most home calculators will do that. But this is more of a computer calculator, and most computers, including like I tried to calculate it in Google. Google has the built-in calculator. It defaults to radian mode and will give you the wrong answer. So you have to be careful. That's why I recommend, rather than doing this, pressing these buttons to calculate that angle, use a sheet of paper like this. And so what you do with this is you look and see the two pieces. Sine theta. So I'm looking for a sine, and it's 0.8509. So I look at the sine column until I find the closest number I can to 0.8509. And here we are right here. It's going to be somewhere in between these two. 8509, probably closer to 58. I will take 59 as an answer as well, but it's going to be 58 or 59 degrees. And for our purposes, that is fine. This, I find, is less likely to have errors. Students that have used this when I've provided it tend to make less errors because they accidentally hit a button on their calculator that put it in the wrong mode. And I've had students that have done entire tests and got everything wrong and couldn't understand why. You'll get weird negative numbers that you shouldn't be getting. So I highly recommend you use the sheet. There's a copy of it on the computer. You do not have to print it off. You can use it on the computer. It works just as well. But if you want to use your calculator, then again, converting, you're either pressing sine in the number, which is pretty straightforward, or you're pressing, but to go from the decimal, the ratio back, you got to press the second sign, and you'll get the sign to the -1 on your calculator. So that babble out of the way, let's actually go about applying this for some questions. So solving for missing sides in triangles. Okay, there's two situations that'll happen here. We'll do a couple examples. So the first thing you need to do is label your triangles. I will not be labeling your triangles. The red pen is because, again, I had pre-filmed this and had to erase everything. I had to redo the audio. So you label your triangle first. So in this case, I have my hypotenuse. There's my opposite because it's across from the working angle. There's my adjacent. And so now, remember the phrase SOHCAHTOA will help us pick our ratio we need. In this case here, don't use the A. Why? There's no value there. There's no number, there's no variable, there's nothing there. I need numbers and letters to actually solve something. So I have the X I'm looking for, so I have to use that. 47 degrees and 11. Those are the values I have. So opposite and hypotenuse, that's going to be sine. Sine theta equals the opposite side over the hypotenuse side. Now I fill it in. Sine of 47 degrees equals the opposite side of X over 11. Then what I do is I either type in sine 47 in my calculator, or I pull out my sheet and I look up 47 and get the matching sign, which is 0.7314. 0.7314 equals X over 11. And now the last step is just simplifying that, or calculating that ratio by multiplying the X, the 11 by the 7314. And when I multiply that out, I get about 8.0. So what I did, again, I labeled my triangle. Got rid of the side I didn't need because there was no value to it. I wasn't looking for it. I didn't have a number there. Got rid of it. And then used those two sides, filled in the formula with everything that I had, and then just did some simplification. If for some questions you get two sides given to you and you have to find that, then you'd have the option of picking either one, but you can't use both because every formula you need to use the X and then one of these two. Okay, one more example in the case of the X on top of the fraction here. So in this case, again, label your triangle, hypotenuse, opposite, adjacent. I have the adjacent side and the opposite side with values, so those are the ones I'm going to use. We're not going to use hypotenuse. That is TOA, so tan, opposite and adjacent. So tan 36 equals x over 16. Okay, take your calculator, type in tan 36, or look it up in your table, and you should get 0.7265 equals x over 16. Now, we just multiply the other side by 16. So that's going to equal our x. And in this case, we get 11.6 as our x. So our missing side there is about 11.6. So that is the case when the x is on the top. Very, very similar case when, find my note here, there it is. When the x is on the bottom. Okay, so a couple examples with the x on the bottom. So in this case, labeling my sides, opposite, adjacent, hypotenuse. I got the opposite and hypotenuse, so that is sine. I fill in my values. And in this case, the x is on the bottom. Start off the same. 0.8660 equals 17 over x. So I'll just continue that up here. So now I got to take that x, get it to the top. I'm going to do that by multiplying it by 8660. And then I'll divide the other side by 0.8660. And that's going to get me 19.6. Okay, so flip the x up, drop that down for the division, and then you'll get your result. Now, if you notice, the x and the 0.8660 just switch spots from here to here. If you want to skip this step, you're welcome to do that. That's what I'm going to do in the next question. I tend to do that because it's just one less piece to write, and it makes our videos faster. And again, it's just doing 2 steps in one. This one's going to be cos. Sorry. The angle is 32 degrees. I got x here as the hypotenuse. I got 28 as my adjacent after I've labeled it. Again, make sure you're labeling them beforehand. Opposite, again, is the furthest side away from the angle that you're working with. Fill in your values. What I got? Cos 32 equals 28 over x. Calculate cos 32. Either use your table and look up 32, the angle 32, and then go over to the cos column, or put it in your calculator. 28 over x is left over. So I got my 8480. I'm going to take that 8480 and the x, I'm just going to flip them. So the x goes on top and the 8480 goes on the bottom. Okay, I'm skipping that step like I said up here as I go from there to there. And so x is equal to 33.0 in this case. So those are some examples of finding the missing side. Now, there's also the case where you need to find the missing angle. So I got an example of a sine, a cosine, a tangent relationship here to find those. So label your triangle. We got the adjacent side, the opposite side with values, and we're trying to find this angle here. So that's my working angle. I'm going to use tan theta, which is opposite over adjacent. Fill in the values. Tan x equals 14 over 19. That's tan x equals 0.7368. So I'm just dividing 14 by 19. Now I can use my handy dandy table, go through the tan column looking for something close to 7368. So there's the tan. My tan column is this third one here. 7368, gonna be somewhere around 36, 37, probably closer to 36. So I'm gonna call that x equals 36 degrees. On your calculator again, that's where you'd press the second tan to get the actual angle. The next one here, same idea, label your triangle. We got the adjacent and the hypotenuse. So we got cosine x, which is 10 over 27. Just skipping some steps here to get through this because this is getting to be a longer video. Divide 10 by 27. I'm going to get 0.3704. Okay, so I filled in the formula, divided the numbers, just pulled up my handy calculation table, or press second function cos on my calculator, and it works out to about 68 degrees. Last one, same idea, opposite side, adjacent side, hypotenuse. I got my opposite, I got my hypotenuse. That's a sine type of question. So sine x is going to be opposite over hypotenuse, or 14 over 20. That's going to give me a 0.7 as my sine. Plug that 0.7 in my calculator, pressing second sine, or look it up in my table and find the matching angle, which is going to be about 0.44 degrees. So again, label your sides, opposite, adjacent, hypotenuse. Pick the two sides that you are using. Use those to pick your formula. Remember, SOHCAHTOA is your picking, is an easy way to remember what formula is which. Fill in your values and then do your calculations. Press sine if you have the angle. If you're looking for the angle and you have the ratio, second sine, or cos or tan.